Lesson 1.2 notes, transformations of linear and absolute value functions. Um, if you can't tell here by looking at the I can statements, the goal for the day when it's all said and done is to apply concepts and transformations learned in lesson 1.1 and now be able to write, right? Every goal that we have for today is the ability to write functions that involve translations, reflections, stretches, shrinks, or any combination of those transformations. So let's do it. Let's get into it. It's I don't know. I feel like we can make it doable, manageable time wise, but that's getting into it. So here we go. First note, definitely add to your. There's going to be two sections in your notes here. First one is what I would call, and this is just a Mr. Kroll term that I call it, is whole function transformations, where we do something to the entire function. So we'll have three of them that go in here. Okay, and we'll try to do what the transformation is, what the rule is for it, and then look at what does it look like in both linear and absolute value functions. Okay, so here we go, starting at the top. In no, we'll number them just so we have. There's six total. There's three whole function transformations, and then there's three what we'll call just the input transformation. So we'll get to them here. So six total. Transformation one. If we want to do a vertical, or we're asked to perform a vertical translation. Okay. That would involve a whole function transformation. The rule basically is if you want to go up, okay, we'll try to separate this here a little bit. If you want to go up, we would add to that k value, right? We're talking about either absolute value, which looks like, our generic kind of absolute value, x minus h plus k. We talked about in the previous lesson that k involves a vertical translation. So if I want to continue, or I want to do an additional vertical translation, we would add, that says 2k. I'm trying to keep it so I can squeeze an example in there. Add to k, keep going up. Or if I want to translate down, we would subtract, that's an arrow, subtract from k. Okay, so if you want to go up, add to k. You want to go down, subtract from k. So we'll see space-wise here. Can we do it? Just a little mini example. Like I said, we'll try to do a linear and an absolute value example. If I want to take, let's say I have a simple function, y equals 2x plus 3. And I'm being asked, or I'm told, I'm directed to, take that linear family function, and I want you to translate it down 5 units. Okay. Right, we want the direction or whatever, the assignment or the quiz or the test, whatever says, take this and translate it down 5. What's the rule? Down, subtract from k. So on that 3, I'm going to try to save space here without showing it exactly. We're going to subtract 5 from that 3. So the resulting function would be y equals 2x minus 2. 3 minus 5 is negative 2. There we go. Okay, doable, right? And not much would be different, although let's do it. Let's take the time to do it. If, let's say, my original function is an absolute value, x minus 6 minus 7. If you can't tell, I'm just making these up. And then I would say, hey, you know what? Let's translate that up 2 units. Okay. So up says, all right, what's the rule? Add directly to k. We want to go up. We're going to add 2 to k. There's my k value. It's in that k position I've referenced now a few times. So we would end up with y equals the absolute value of x minus 6. Notice nothing's going on inside there. All right, that's h. We're not going to address that. And I'm going to add negative 7 plus 2 because we're going up. So we took everything up, and now we're at minus 5 there. Okay, so hopefully that makes sense. That's a vertical translation. That's what that would, that's how we would do on any linear, right? There's my linear example. There's my absolute value example. Up or down. Pretty straightforward. Okay, awesome. Okay, what's next? We're just going to have to slide. Obviously, you can pause and go back and re-add anything. Next one. If we would like to perform a reflection over the x-axis, so x-axis. Okay, so that would be the transformation, reflection over the x-axis. What do we got to do? Okay, the rule says then, again, this should be in that column. The rule would be to multiply the whole function. I know we're in the whole function section, but I'm reiterating it. Multiply the whole function by -1. That's the rule. So this one can be potentially a little bit more, just there's some simplifying things that we got to watch out for when we're doing this. So let's take a look. Here we go. The direction would be, all right, here's your original. Y equals negative 5x. This is my linear example, negative 5x plus 4. Now we know how to translate that up or down if we wanted to. We could also, hey, you know what? The direction is reflect that over the x-axis. I'm just going to write it right here real short. Over x-axis, right? It would say that. I'd have that in the directions. It would be, I would be told to, hey, take that function and reflect it over the x-axis. What does that mean? Well, I need to multiply, here it is, multiply the whole function by -1. So and the reason I'm kind of hammering that whole function means I want to take this whole thing, negative 5x plus 4, and multiply that by -1. So I'm using parentheses, and I'm actually going to make sure, and the reason I'm using parentheses is to make sure I distribute that -1. Ultimately, what happens? We change the sign on both terms. Y equals, so the multiply right here, we end up with positive 5x, and then we end up with -4. I don't know why I changed color there, but anyways, that's where we would end up, 5x minus 4. So I've reflected this original negative 5x plus 4 over the x-axis, change the sign on both of those. So really not that bad, I mean, simplify-wise, but it's easy to also forget and just go, oh, positive 5x, and forget to change the sign on the -4. Let's see what that looks like. It can be even with the absolute value. There's a little bit even of a twist on this one too. So let's say my original function y equals absolute value of x plus 4 minus 6, whatever. And the direction would be, same deal here. If you want to write it, you can write it over the x-axis. Reflect this, right? I don't even need to see the graph, right? We don't need to see it, but I could just, mess with the signs a little bit. How does this work? Well, here, good thing you asked. Here's how we do it. We would take, let's just write it, over x-axis. Okay, reflect that. Okay, I can do that. Slide down a little bit. I would still probably put parentheses around this entire thing. There's my absolute value bars. There's my -6. Okay, that whole function got put in parentheses. And what did the rule say to do? Multiply the whole thing by -1. No problem, right? Be careful right here. Here's where mistakes get made. Just because of properties of absolute value and how this works, we're going to distribute, but when I go to distribute this -1, I cannot distribute it inside or within an absolute value. This is kind of like one big term all lumped together. They're like a wall. I can't distribute in there. So I can't make it -x. I can't make it -4. That -1 just gets dropped kind of in front of the absolute value as x plus 4. So that stays exactly how it is. It's just now it's negative, the opposite of the absolute value of x plus 4. And then I still got to make sure that that negative 1 gets distributed all the way to the other side of the function. So when it's all said and done, those are absolute value bars. To take this original, y equals absolute value of x plus 4 minus 6, to reflect that over the x-axis, again, we're treating this like one big term. That becomes an opposite here. And then the negative 6, just like before, became positive, but just making sure that everyone knows can't distribute inside there. All right, so there's number 2, 2 down, 4 to go. All right, keep her moving. I'll slide it. We got one more whole function one. What is it? I forgot. What is it? Oh, a vertical. I actually did kind of forget. Vertical, stretch, or shrink. The nice part here is it's the same rule for both, so you don't need to know a different rule for stretch versus shrink. Rule says, hey, how do you do this? Multiply. It's very similar to the last one. Multiply the whole function. I'm going to write it again. Let's just say by whatever factor you want to stretch or shrink by. You want to stretch it by a factor of 5, multiply the whole function by 5. You want to stretch it, or you want to shrink it by a scale of 1/4, multiply the whole thing, the whole function by 1/4. These last two can be used together. So we'll get to the combination stuff here in a second. But if you're ever asked, hey, you know what? I want you to do two things: reflect over the x-axis and stretch something by a factor of 5. Well, we can do those together because they follow the same rule. We would, instead of multiplying by 5, negative 1 first, and then multiplying everything by 5, that would result, we get the same result as if we multiplied everything by negative 5. Does that make sense? So like I said, we'll get to the combination stuff, but they're right here. They go hand in hand. What we're going to do right now for our example is going to look very similar to what we just did. Okay? So linear absolute value, let's do it. Here's my original. Y equals, 3x plus 1. Okay? The direction would be to, let's say, stretch by, and it's going to give me a number. It's going to say stretch it by a factor. Let's do it. I said it 10 times already. By a factor of 5. Okay, great, awesome. It's going to look just like that other linear example. I'm going to take this whole function, 3x plus 1, and multiply, just making sure that I distribute here and here by 5. So we'd finish up with y equals 15x plus 5. There we go. Not bad. Let's do a shrink, and let's do a shrink on an absolute value. We're staying consistent here, doing one of each example. Maybe need a little bit more room. So we could have something like, how about this? Y equals 3 times the absolute value of x minus 7 minus 9. Ooh, nasty. And I want to say, hey, the direction is shrink by a factor of, what am I going to go with here? How convenient, 1/3. Shrink by a factor of 1/3. Say, no problem, I can do that. Y equals, big parentheses, we need to squeeze everything in there. 3, absolute value, x minus 7, absolute value minus 9. Close them up and say, yep, let's multiply everything by 1/3, just like before. I'm not going to distribute into the absolute value, but any number out front here still has to get multiplied by 1/3. Now, again, if I'm making up the answer or the examples here, of course, I'm going to pick a number that works out nicely. 1/3 times 3 is 1. So I'm not going to write a 1 there. 1/3 times 3 is 1. It just kind of, that term is still there. It's just a 1. I'm not going to write it. So x minus 7. All right, there's a little invisible 1 out front here. And then, again, not forgetting to get that 1/3 all the way over here. 1/3 times 9 is 3, so minus or negative 3. That's where we would end up. Not bad. Okay, we can do those in general. I would say just big picture, whole function ones, which is what we're doing here, tend to be a little bit. I don't know. People tend to do better with them, but I don't think that the input, just the input ones, are much tougher. So we do need to know the rules, though. Hey, multiply the whole function by that whatever factor. Multiply the whole function by -1. You're technically adding to the whole function here when you're doing the adding subtracting. It adds it. The way it simplifies is just it works with the k. One while I'm here, why not? Let's say that was my original function and said, hey, translate that up 5 units. What's my k value right now? I say, I don't have a k value. You do. There is a k value at the end. What is it? It's just 0. So I would just add 5 to this. We'd end up with 2x plus 5. As far as if I wanted to translate that up 5 units. Okay, I just saw it, reminded me, just worth mentioning, something we mentioned in class. Okay, all right, let's keep her moving. We have 3 just the input ones here. Okay, so again, that's a Mr. Kroll phrase. You're not going to find that, I don't think, in the textbook. They're a little bit more technical, which is generally the case, but it's the same material. I'm trying to give it a little bit easier maybe to follow here, okay? So here we go. Let's do it. Let's just jump in. We're up to number, 4. There's not any meaning to the numbers. It's just a matter of me keeping track of making sure I hit them all. What else can we do? Let's kind of stay consistent here. We could translate, but now we could go left or right. What am I doing? Right, left or right? That is just the input. All right, so what do I mean by that? The rule says, the rule is we're still going to add or subtract. If I want to go left, this is still backwards. So if you want to go left, in my head at least, I think if I'm moving left, I'm subtracting, I'm decreasing, but it's actually backwards. Left, you would add to x. I'll show you what that means here in a second. And if you want to go right, again, in my head, I see that, hey, I want to move something to the right, positive to the right, right? We should move something to the right. We should be adding. It's the complete opposite. You'd actually subtract. We'll just abbreviate. Subtract from x. Okay, so this one can get a little bit weird with both absolute value and linear. So make sure you do the example. I don't know why you wouldn't. Here we go. Let's say y equals, I keep picking the same numbers, so what? 2x minus 3. Who cares? All right. And your direction would be to, hey, you know what? I want you to take that and translate left 5 units. Okay, I can do that. I at least understand the question. Take that line and translate it to the left 5 units. What did Mr. Kroll say? Hey, if I want to move this left, I need to, now watch this here, just to the x. These are just the input transformations. So what does that mean? It basically means I need to peel everything away from the x. So watch this. The 2 is getting peeled off the x. And what do I mean by peeled off? I separate it with parentheses. Peel that 2 off the x. It's separate. Now I've got the x by itself. What do I need to do with that? I want to move it to the left. So I should be adding 5 to the x. So that's what I mean by just the input gets 5 added to it. I've separated it. I've isolated the x. And I've added 5 directly to the x. And then just don't forget, hey, there was other stuff here. There was still a minus 3. Okay, so that's what I mean by peeling stuff off and separating things from the x. We isolated it. What makes these ones maybe tougher is kind of the simplify part of it. Okay, so to finish this one, I would say what? We usually don't see linear functions written like this, right? Where there's a 2, x plus 5. That's just a weird way to write a linear function, and I wouldn't want you to leave it like that. I would say, hey, let's finish this. Let's distribute 2x plus 10. And then we have that minus 3 that we can get the 10 and the 3 combined. So 2x plus 7 would be like your final simplified. We've taken this original 2x minus 3 and finished it. We've translated left 5 units, and now it looks like 2x plus 7. This is where you get the argument where, wait a minute, hold on, Mr. Kroll. Can't you say that we just went up 10 units? And you'd be correct. The hard part is you'd kind of need to know, like, well, going up 10 on this particular function is the same thing as going left 5. Where am I getting that 10 from? If I add 10 right here vertically, going back to the previous notes, if I add 10 to the k, that's going to take us up 10 units, and it would leave our y-intercept at 7. If I lost you there and you're like, well, wait a minute, I like what you did with the plus 5, just stick with the rule then, okay? Don't try to get hung up on, you can do it one way or the other. Okay, let's do an absolute value one. Just an example here. We'll make one up. I need a little space. Let's go y equals absolute value of x. Here's the original, minus 4 plus 6. Same numbers over and over, whatever. Okay, and then we want to take this and translate. Let's do a little bit different. We want to go, what did we do in the last one? We went left 5, so let's take this one right. 2 units. Okay, slide this whole function to the right 2 units. So we do have to get to know those rules. Remember, here's how it goes. If I want to go right 2, you would think add, but it's actually going to be subtract, okay? So maybe you just make a note to yourself like, hey, subtract 2. All right, now let's actually do it. Just start copying. Absolute value. Oh, I finally hit the x. I'm going to isolate that x right now, just like we did in the last one, right? These are just input ones. Take the x. What did we say we wanted to do with it? Subtract 2. So x minus 2. It's isolated. Don't forget now, there's still this minus 4. Absolute value. There's still this plus 6. Good. So simplify wise, there were some questions, and there usually is here. How do I simplify this? This isn't a distributive situation, right? We're not multiplying by negative 4. This is originally minus 4, and it's still minus 4. It's almost as if these parentheses don't exist. X minus 2 minus 4. So it's really like, if you want to see the steps of it, x minus 2 minus 4, and then that plus 6 is totally separate. But this at least allows me to simplify a little bit, right? We can get that negative 2 and that negative 4 together. So this one would finish as absolute value of x minus 6 plus that 6. Okay, that's a little higher level, I think, as far as seeing some of that stuff and knowing how to simplify it. So yeah, it is what it is. Okay. Four down, 2 to go. We're doing okay. Let's see, what colors haven't we used yet? Go with blue, my favorite color. Next one, let's go. We haven't even talked about this. This didn't come up in the previous lesson, but we could reflect over not the x-axis, but the y-axis. That could be, you could be directed to do that type of thing, which is fine. Okay, I'll show you how to do it. We're going to multiply. What's the rule say? The rule says to multiply, not the whole function, but just x by negative 1. Okay. Yeah. So there's obviously some similarity there. We're multiplying by negative 1, but I'm not going to try to find it here. But For an x-axis reflection, it's the whole thing gets multiplied by -1. If we wanted to go y-axis, we'll multiply just the x by -1. That's the rule. Okay, let's do it. Let's do a linear. Let's do an absolute value. Start with linear. Here's my original. Y equals -3x plus 4. Same numbers again. I keep forgetting what I've used. And the directions would say reflect over or reflect about the y axis. Sweet, awesome. These three that this reflecting over the y-axis and the next one will do too, all involve that what I call peeling off numbers of the x. Okay, so here we go. Y equals, I just start writing. Have I reached x yet? Nope. I copy down this -3. All right, I'm about to write x, but before I do it, I'm going to separate it. I'm going to peel that that -3 off of it and just go -1 times x. Okay, and then we're isolated. Just the x got multiplied by -1, but I keep going with the plus 4 because that was all part of the original function. Okay. Now simplifying wise, this is just like -x. So a lot of times you probably wouldn't see this. You'd see it written more probably -3 times -x plus 4. I guess it doesn't hurt to have that -1 in there because maybe that reminds you that, oh, wait a minute, hold on. I need to multiply -3 times -1. So when it's all said and done, where do we end up? Y equals, what is -3 times -1? Positive 3. Okay. So long story short, with linear, what's the deal? The x value, or the coefficient, your slope, the number in front of your x term is going to change signs. That's with linear. That's how it's going to happen. But your y-intercept should stay the same. We're basically switching the sign on our slope. All right, let's try absolute value. Let's go with y equals, let's put a number in front there. 2 times the absolute value of x minus 5 plus 7, whatever. Okay, now this one actually, I think it ends up being maybe a little bit, whatever. I was going to say simpler, but let's just see. Let's take it as it comes here. So what does the rule say? I want to reflect over, or what are we doing here? Reflect over the y-axis. Got it, no problem. I can do that. Start writing. Y equals 2 absolute value. Oh, here we go. I'm coming up to the x. Let's isolate it. Let's write a -1. We're going to multiply that by the x. It's isolated minus 5 absolute value plus 7, right? So I essentially copy the original. Everything's identical except I attached a -1 to the x. Now, for the sake of this, let's drop here. I'm just going to simplify this in one step right now. -1 times x. Most of the time, I set it above. I'm just going to copy all this other stuff. You would see just kind of written as the opposite of x, minus 5 plus 7. It's a little bit hinky, or like you wouldn't normally, I would say it's maybe not like the best form to leave this negative in front of the x here. But if I'm being completely honest, for the sake of what we're doing here, I'm okay with us leaving it like that. So this is actually where we would leave it. There's nothing else to combine here. You could what you would do is you factor out a -1, the absolute value of -1. It kind of goes away there, and it actually ends up being x plus 5. I'm not even going to show it, but I guess the point is, with absolute value, where I originally said it might be a little simpler is, the only thing that's really going to change with absolute value is nothing outside. The 2 stayed, the plus 7 stayed. And actually, the only thing that changed that was different is it was the opposite of x. It went from x to the opposite of x. And we can leave it like that. I'm okay with that, okay? That should kind of work out that way, I think, in just about every case. With absolute value, all right? One more. Oh, man, my throat's getting dry. Here we go. Last one. This beautiful brown. I saved it for the end. And not to hey, this is probably ends up being one of the tougher ones just because there's the most to consider. What haven't we done yet? We've translated up and up and down, left and right. We've done it. We've reflected over the x-axis. We've reflected over the y-axis. Just got it done. We've stretched and shrunk vertically. The last one is we could stretch or shrink. I think we wrote it slightly different, but we could stretch or shrink horizontally. So you could write, if you want to stay consistent with your notes, write it as a horizontal stretch or shrink. Okay, that's the last one. Okay, great, awesome. Horizontal stretch or shrink. How do we do it? This is the part that I think makes this hard. We're going to multiply just x, so that part's not changing. We're going to multiply just x, so we're going to do the peel off, the isolate stuff that we've been doing in the last two examples. Just x by the reciprocal, oh no, there's a word that we probably haven't heard for a while, the reciprocal of, that meant to be of, whatever the factor we're being asked to stretch or shrink by. So if it says, here's an example, maybe just to kind of clear this up here. If it says to shrink by a factor of 1/4, say, okay, sweet, I can see my factor, shrink by a factor of 1/4. I'm going to multiply just x not by 4, or how I just said it, not by 1/4, but by the reciprocal of 1/4, which is 4. Okay, so the reciprocal, I'm just going to say we multiply everything by 4 in that case. So that's a little bit weird. Let's do a stretch one. What would stretch look like? If it said stretch this thing horizontally, I want you to stretch out this graph, stretch out this function by a factor of 5. What's the reciprocal of 5? It's basically flip it over. Right now it's 5 over 1. It's got to be, we're going to multiply everything by, or the x, I'm sorry, we'd multiply just the x times 1/5. Okay, we'll do it. We'll practice it here. It's really the last thing we need to do before we actually kind of see some of the problems, but just want to make sure that that's what makes this one tough. You got to remember horizontal means multiply just x by the reciprocal of the factor. Okay, let's try it. Let's see how we do. Here's my original. Y equals 4x minus, let's keep it even here, 10. All right, sweet. And now I want to do a horizontal, so that it has to say that horizontal. I should have wrote that on the vertical one. Horizontal stretch by, let's just keep it simple, 1/2. Stretch everything horizontally by 1/2. Oh, that doesn't make sense. I'm like trying to think a step or two ahead of you and I'm screwing it up. If it's a stretch, the number should be greater than 1. So it would say stretch everything by a factor of 2. Horizontally stretch it by 2. Okay, let's do that. Here's where you might make that note to yourself again and say, all right, multiply. What am I actually going to multiply? Not by 2, but by what? 1/2. All right, so the factor is 2. It's a stretch factor of 2. But for me to actually do the stretch, I need to multiply the x by 1/2. Okay, hopefully I didn't lose you there. All right, so let's do it. Peel all this stuff off. Y equals 4. It gets peeled off. I multiply the x by 1/2. I isolate it, and I've still got my minus 10. So this one, again, isn't terrible in the sense that we can do that. What's 4 times 1/2? I mean, I'm picking numbers again that are convenient, but it's 4 times 1/2 times x. It's all multiplication. Don't let these parentheses let you do weird stuff. You're not going 4 times 1/2, 4 times x. It's nothing like that. It's 4 times 1/2 times x. We can just multiply these two things. So when it's all said and done, we end up with 2, 4 times 1/2 is 2, 2x minus 10. y equals. Okay, does that kind of make sense? Well, we got to practice it. We got our last example on the absolute value. Let's get it done, and then we'll see what we can do. Okay. All right. I'm going to have to look back and forth. So let's see. We're going to go y equals, it doesn't matter what's out front here because it's not going to get touched. 10 times the absolute value of, you could see a number in front of it. Let's do this. 3x plus 7. That's fine. Leave it like that. There's no k value. The k value is 0. Okay, and what do we want to do with that? What did we do before? Let's do a horizontal shrink by 1/3. So horizontal, doesn't matter. Shrink by 1/3. Okay, so I make my note like, oh, okay, Mr. Crow is asking me to shrink this by 1/3. That means for me, because it's horizontal, I need to multiply just x by the reciprocal of this number. So multiply x times 3. Okay, so it actually ends up being not terrible. Y equals, peel everything off. The 10 stays separate. The absolute value is separate. The 3 is getting peeled off. All right, here we go. I'm going to multiply just the x by 3. That's the reciprocal. Close up your parentheses, plus 7, absolute value. So it works out to be very similar to what we just saw. How much stuff needs to get simplified here? It's not a distributive deal. It's literally 3 times 3 times x. So do your 3 times your 3, and we'll finish it with y equals 10, absolute value 9x plus 7. And we can leave it there. We talked about this one in particular. There's not much you would want to do. Like we couldn't factor out a 9 or anything in a 7. So it is what it is. All right. It's just kind of using the rule and say, all right, that x is now 3 times bigger. It said shrunk it by 1/3. That's just how it works. Oh, that was kind of a long note, I guess. I mean, but that's new stuff. I'm guessing most of us haven't done things like this. So it makes sense that we got to take our time and do it right. All right. I did put here, I don't know how much you need to add. If you want to add it and pause it, it's basically, for any of these problems, we got to decide, is it just the inputs or is it a whole function one? So that just comes down to knowing which ones are the whole function, vertical translation, reflection of the x-axis, vertical stretch or shrink, or is it just the input one? Left to right, reflect y-axis, stretch or shrink horizontally. Okay, so that just comes down to knowing those ones. And we went through all these processes. So I don't know if this is necessarily, that's kind of the same deal. Just the inputs. Isolate the input, use parentheses to isolate it, and then simplify. Whole function usually involve parentheses around the whole function, and then maybe a distributive property, combined like term stuff. So it's up to you. We didn't add these in class. I don't think we need to. Last thing that we should add for our notes before we look at a couple examples, I think this is it as far as note-wise, is we can do, and I mentioned it at the start, we can do more than one at a time. Okay, it might ask me to, hey, here's a function. First, reflect it over the x-axis, and then second, after you reflect it over the x-axis, translate it left 4 units. Something like that. That's just an example. Or reflect it over the y-axis and then stretch it vertically by a factor of 4. Stuff like that. The big takeaway is we need to do them one at a time in the order listed. Okay. There are a few, and so I'm like kind of contradicting myself here a little bit. There are times when you can kind of combine a couple of them, like the multiplying by -1 and then multiplying by 4. We said, hey, that's the same as multiplying by -4. You can do stuff like that, but we'll see a couple examples here that the order is going to matter. You're going to get a different answer if I do them out of order or I try to do too much at one time. Okay, let's start simple here. Example 1. They're basically going through stuff that we already have. So I'm going to fly through these. I don't want to make this a 2-hour video. Translate. Okay, so whatever. Starting with translations. All right, take this original function. Here's my original. Remember, f of x is just like y. We did all ours with y. It's fine. F of x equals 2x plus 1. What's it asking me to do? Translate it 3 units down. What do the rules say? I'm not going to click back and forth. You can see your notes. If I want to go down, I need to subtract directly from the k. So if you want to see a step, that's fine. I'm going to go, my original is f of x equals 2x plus 1. Here's my original. What does my rule say to do? Subtract, because we're going down. So I'm going to subtract directly from the k. Subtract 3. So my final result here would be f of x equals 2x minus 2. Okay, that's probably one that you can look at and say, hey, you know what? Can I just go to this, Mr. Cole, and write this for my answer? I'd say, yeah. I'm not in the business of making life. Hey, you got to show every single step. Now, there will definitely be cases that it's going to be in your best interest to show steps, but I don't know if that's one of them. This might be an example of one right here. This one is an example of one. Write a function h. So it's asking us, I should change this. My bad on that last one. I'm going too fast now. It said come up with a new function g. So I should call this new function g of x. That was my fault. This part B is asking us come up with a function h. So a new function h, whose graph is a translation 2 units left. Okay. So let's see here. Here's my original, f of x. Actually, as I'm writing the original, I'm going to kind of sneak this in here. All right, left and right. That's one of those just the x. I'm kind of going through the process of what you should be going through in your head or as you're doing one of these problems. Left and right. That's a just the x one. So this is one that I got to peel that 2 off the x. And then let's see, left. I want to go left. You would think subtraction, but it's not. It's backwards. If I want to go left, I actually need to add how many units? 2 directly to the x. Everything else stays the same. So we're working off of this one right here. So 2 peeled off the 2 and the plus 1. This is one of those ones that it's a little bit more on the simplify side of it. It's not terrible. You've distributed a million times, hopefully up to this point. We're going my 2x plus 4 plus 1. So the result, the h, right? I'm using this right here. H of x is equal to 2x plus 5. All right. I think most people would say, yeah, that A is easy. B is going to take some practice. We got, just to kind of see and know what we got to do there. Number 2, keep it moving. We'll probably skip over the on your owns because we did those ones as part of our notes. We did a lot of those ones. They're going to be very, very similar. I'll make sure, though, we hit one of each here. Okay. What's next? Reflections. We got an x-axis. We got a y-axis. No problem. Let's do it. It's an absolute value this time. We'll just kind of mix and match. All right. Great. I'm going through my head here. X-axis. I got to check my notes. Is that a whole function or just x? That's a whole function a transformation. Okay, we can do that. What did the rule say? It said take the original. So here's my original. It's a whole function, x plus 3 plus 1. Take the original, the whole thing. This is where we put the parentheses on the whole thing and multiply the whole function by -1. We've done one like this, right? Just with different numbers. We're going to make sure we distribute not into the absolute value and all the way to the other side of it. So my result here, g of x equals the opposite of the absolute value of x plus 3 minus 1. Okay. I should have said, obviously I'm doing these examples. These are perfect opportunities for you to pause, try it, and then listen to me go through them. That's my bad on my part. That's always kind of the case. I just jump in and do the examples. You have the ability to pause and try them. You should be doing that. Okay. I got to be able to see it a little bit here. Now it's a y-axis one. So on the same original function, forget all this stuff, but let's do a y-axis reflection. Actually, which is one of those that ended up being kind of nice. Right? So y-axis, check your notes. That is a just x getting multiplied by -1. So when it's all said and done, what ends up changing here on this one? We said absolute value stays. Let's do it. Let's peel off the x just by itself. We're going to multiply it by -1. We've got the plus 3, the absolute value, the plus 1. And then just same thing. Don't leave it. If you choose to kind of show it like this, let's simplify it, and we want to make sure we incorporate h here. So h of x, what has to get simplified? Really just write, kind of lose these parentheses, and we would just write that as the opposite of x plus 3 plus 1. Okay. We're getting there. I'm trying to keep it manageable. Circle it. There's my answer. I don't want to go too fast because then I'm going to screw something up and then I'm going to have to fix my video. All right. I think we're good. We'll come back. These are ones that you can see me about. I'll put them up there. You can try them, but that would be something you can, hey, I tried that on my own. Can you just check these? Are these right? Yeah, absolutely. I'll let you know on some of that stuff. The last ones we got here, okay? It's a stretch and a shrink. I've got it set up as a horizontal and then a vertical, so a little different order. That's fine. Oh, look at that, 1/3, 2, okay? And it's on an absolute value, so I think that'll be good for us. So here we go. We are doing a horizontal. That's key. I need to see that, so identify horizontal. Factor of 1/3. As soon as I see horizontal and 1/3, what should I write? Times 3. Do the reciprocal stuff right away. Just, hey, I can see it on paper, times 3, the reciprocal of 1/3. What am I doing with that 1/3? This is probably 1. I don't know, I don't want to rush it, but if I go, could I jump right to my answer right here? Let's see, g of x. We're basically peeling everything off. What one thing has to get multiplied by 3? Just the x. So that I'm going to multiply just the x right there, 3x. I would originally probably add parentheses around it, but then the only thing that changes is those parentheses kind of get dropped. Maybe, I don't want to ruin it. We're doing so good. Minus the original 3, minus the 5 that's original. So everything stayed original. Other than, hey, I isolated the x, I multiplied it by 3 because it was a horizontal, the reciprocal. So yes, my final should be g of x. We almost went there, and then I thought better of it and just said, hey, let's do it in the 2 steps like we've been doing. There's my final. All right, cool. Last one. Last kind of just reiterating some of the stuff that we had done already. H is going to be a vertical stretch by a factor of 2. So just make sure you don't mess this up. That, hey, it's vertical, it's 2. This one, what I see is what I get. Like, I want to go times 2. Don't start flipping everything. That's definitely something that happens. People start like, hey, reciprocal. I got to flip everything. That's not the case. Okay, so here we go. Let's see, h of x, this is my new one, is going to be, and I'm going to do this in 2 steps because I think it needs it. The whole function, x minus 3 minus 5, that whole function needs to get multiplied by, what do we say, by 2. Okay, how did I know whole function? We just have to know that vertical stretch or shrink is always a whole function one. So it's that idea we saw a couple ago where I'm going to distribute in front of the absolute value all the way over here and finish up with h of x equals 2 times the absolute value of x minus 3, right? We can't distribute in there, minus 10. All right. There's another section here. I'll put it up, pause it. If you want to do any of them on your own, I guess it's just a couple stretches and shrinks similar to what we did. The only other thing I think we need to see is the combination stuff. Okay, and I guess maybe we'll do these 2 just so we can get a feel. It's more than one. Basically, just go in the order that they're listed. Okay, this one, look how on these ones, I guess I tend to give you like a simpler function originally, but not always. I thought this one, I got some parent function too. So, all right, let's just read through it. Don't need to rush. Let the graph G be a vertical shrink by a factor of 0.25, 1/4, followed by, I don't even want to read it yet. I don't need to see this yet because I need to do this first one. I need to do the vertical shrink first, and then we'll address the translation. Okay. Now, the nice part is, okay, that's just f of x. What's the rule here? If it's a vertical shrink, that's a whole function. what's the whole function? There's not a whole lot there, right? That whole function, as in just x, gets multiplied directly by whatever I see. So times 0.25. So what does it look like? 0.25, that whole function, even though it kind of looks like we're just doing it to the x, which I guess you could argue we are. That's a vertical shrink. I guess if it was a horizontal shrink, I would have flipped this over, did the reciprocal 4/1. So okay, so I've taken care of this first one. That was kind of a short and sweet one. There wasn't much to simplify. We did the vertical shrink, 0.25. Now off of this current one, this is my new one. I'm working off of that one. On that one right there, we're going to go 3 units up. All right, what is up? Up is a vertical translation. That's a whole function. That's the one where we add or subtract to k. In this case, because we're going up, we're going to add 3 units to k. My k value is 0 right now. So we end up with my result, my g of x, is this 0.25x. And then I'm going to add, what did we say, 3 units onto the k. And that's that. Here's the deal. What happens if I did the plus 3 first? Okay, so that's the answer. That's the result. What if I said, you know what, this plus 3 is so easy. Why don't I just do g of x equals x plus 3? So I did the vertical translation first. And then now I'm going to do the shrink next. Well, then I'd have to multiply this whole thing by 0.25. I'm going to get the 0.25x, but I'm sure as heck not going to get the 3. I'm going to shrink it by 1/4. And you say, well, yeah, that's a difference. That's why we got to go in the order listed, okay? Don't do that. Last one. Promise. I don't have anywhere else to go on the slides. Let's see, graph translation of 6 units down, followed by a reflection the x-axis. So these, I guess all 4, the last 2 on that one, so we had 2 of them there, shrink and up, or vertical shrink and up, and then down, and then reflection the x-axis. These are all whole function ones, and maybe I should have came up with better examples. I think though, you should be able to hopefully do, as long as you follow the order, I think you'll be okay. All right, so we're here, we might as well do it. Where's my original? Right here, kind of basic again. So f of x, that's the original. We want to go 6 units down, no problem. Take the original, and then on my k value, which again is 0, if we want to go down, we better be subtracting. So down 6, sweet, step 1 is done. We've down 6 units, translation. Now on this one, this illustrates it as well. Let's reflect on the x-axis. That is a whole. That's a whole function transformation. What do I need to multiply by? Times -1. So that -1 is going to get dropped in here. -1 got to get all the way over there. So g of x equals the opposite of the absolute value of x plus 6. We made it. Hopefully that wasn't too bad. That's a longer lesson. I know that. I understand that. I said it earlier. It's stuff that, again, is new. What did we do? The whole day was based on writing functions based on all these different transformations that we can do. Okay? This will be kind of a year-long thing, so hopefully you're not like, whatever, I'll just skip 1.2. That's one that we got to be able to do big picture-wise, okay? So we're done. We definitely can check these all off. Check. We did them all. That's 1.2 in the books. That's all I got. I will see you in future lessons.